So first we will be seeing the addition operation on the 2D arrays. So two 2D array we have to take in order to perform the addition, that is arithmetic operation on it. So first of all, we know that the 2D array is represented in the logical way. It is represented in the matrix form. So this I am taking, this is the first 2D array and this is the second 2D array. So we know that in 2D array, two dimensions are there. That is the first dimension for number of rows, second dimension for number of columns. So the very important thing, when you perform the addition operation, the very first question comes actually that whenever we are performing the addition, so in that case, whether these 2D arrays will be having the same number of rows and columns, or if it is different, that is here the first 2D array is having rows and columns, and that is different as compared to the rows and columns of the second 2D array. In that case, whether we can perform the addition operation or not. No, you cannot perform if number of rows and columns are different for the first and for the second. You cannot perform in that case the addition operation. So this is the very important thing in this operation. So you have to keep in mind that the order should be same, then only you can perform the addition. So you can see here this example which I have taken. I have considered this 2D array having number of rows to be 2 and number of columns as 4. So this is the first 2D array by the name that is A, and the second 2D array by the name as B. So first 2D array, you can see first row, second row, that is 2 rows, and column is 4. 1 column, 2 column, 3 column and 4. So I have to take the same order for the array B also. Number of rows, that is 2, 1 row, 2 row, and number of columns 4. 1 column, 2 column, 3 column and 4 column. So this order I have to maintain, and then in order to perform the operation of addition, what things are required? You have to first of all initialize your 2D array. You can do either the compile time initialization or you can do the runtime initialization. Runtime, you can ask the user to enter the element value and you can fill your 2D array. Know that how to do the runtime initialization. All these things we will be seeing in our program. We'll do the runtime initialization. And this is just an example. I have filled it this 2D array with the values. So that is after runtime initialization, this 2D array, I have taken the example that it looks like this. So how the addition will be performed? So the element that is at the index A is subscript 0, subscript 0. So that will be added with the same element of the second 2D array, that is A subscript 0, subscript 0. We will be adding row wise. That is, we will first add the this first row with these elements, and then the second row of the first 2D array with the second row of the second 2D array. So same positions, we have to add these two elements which are there. So they should have the same index. This is my main function. I'm writing the program in C language. Here when you execute your program, the control comes in this main function. Line by line instructions will be executed sequentially. So here before main function in the program, I'm defining row and column. So I am taking it as 2 and 4. So this macro I will be using when I declare my array, 2D array. So it will be, I will use this macro for the size representation for number of rows and for number of columns. So it is same for both first matrix, that is A, and second matrix, that is B. So therefore you can see in the main function I have taken this array that is A by the name A. This is the first array, and 2 subscript, 1 subscript row. So it is 2, and column, that is, it will be replaced by 4. And another matrix, that is B, and 2 subscript, 1 is for row, that is same number of rows and column. So this I will do. So you can change if you want different dimensions 2D array. In that case it is flexible because you are doing hash define. You have to change here itself. So you have to give the size at the compile time itself. At the runtime you cannot change the size. We have seen in the array. We will do the runtime initialization. We will take a for loop. So I will initialize first this one, actually the very first matrix I will initialize. So I will take 2 for loops because it is having 2 dimensions. Integer, one more for loop. So this for loop is for number of rows, and inside that for loop integer just plus, right? So here 2 for loops. Then I will simply ask the user to enter the element values. Program scanf function is used to take the input from the user on the console. So therefore bracket. So for the outer loop, that is for loop, when I is equal to 0, condition is satisfied, yes. and then it goes inside this for loop. This for loop will be executed for j is equal to 0 till j less than column. So column is how much here? 4. So for j is equal to 0 till j less than 4, that is these number of iterations will take place. So we know that indexing starts from 0 to n minus 1. Therefore this 2 rows are there. So 2, that is the first row is having index 0, second row is having index 1. 4 column is there, index is starting from 0 to n minus 1. Therefore this is the first column having index 0, second column having index 1, third column having index 2, fourth column having index 3. So one by one we are asking the user by calling the scanf function. So nothing is present, we have declared the array, and runtime we are asking. So one by one this for loop will go for the 0th row, for 0th column, first column, second. We are asking user and we are filling in the address of these elements. So if the user give like this 3, 2, 1, 5, these inputs we are filling in the address of this array, what user gives. Then when this whole loop is completed, then again I gets incremented to 1. This condition is satisfied. Therefore for first row, that is for this row, again this for loop will be repeated for j is equal to 0, j less than column. Therefore for this first row, again 0, 1, 2, 3, 4, we are asking the user to enter the element value, and we are filling in the array. So after completion of this, how you will take the input and you will fill here. The user give these values, we are filling here in our array. So this is how we will do the runtime initialization of the first 2D array. Same thing we will do for the second 2D array. So I will write here the code because there is no space here. Again I will take the for loop for, then integer, say I am saying L is equal to 0. 0, that is for the 0th row. We will fill each column. So suppose user give 1, 2, 3, 1, like this, these inputs user give. Again this for loop will be completed once it, after reaching this position, and then again control comes outside the inner for loop, and then L gets incremented to 1. L is equal to 1. For the first row all the elements will be filling. Suppose user give 2, 1, 3, 1. All these values the user give, we are storing at the address of this element. So I hope so you understood how to do the runtime initialization for these 2D arrays. Now the main operation which is there is we have to perform the addition, first A 2D array and second 2D array as B. Now the addition of that we will be storing again in the 2D array. So I will declare one more variable, say sum, and the same number of rows and column. Now what I will do, how to perform the addition operation of these 2D array, it is very simple. Since we are how we have filled this 2D array, we are filling the 0th row first, then we are filling the first row. We have seen the runtime initialization. Similarly, we will take 2 for loops for that, and row wise we will be adding each elements to perform the addition of these 2D array, and therefore I will take 2 for loops more. So this for loop, that is the outer for loop, again as I told you we will be adding the element row wise. So therefore p is equal to 0, p less than row, p plus plus, and the inner for loop for each row we will be then iterating for the column. So therefore int q is equal to 0, q less than column, q plus plus, and then the main operation of the addition. You can see here the sum subscript p subscript q is equal to, we are adding this A, which is the name of the first 2D array, A subscript P subscript Q, plus we are doing this this operation of addition, that is plus, adding this with the second 2D array whose name is B. So B subscript P subscript Q. So we are doing these things. So this addition I am performing and I am storing here in the resultant 2D array whose name is sum, and we are storing element by element. And then I am printing it. So what will happen in that case? For p is equal to 0, this condition is satisfied, yes. And then for the inner for loop, q is equal to 0, q less than column, yes. This comes here. Therefore, this sum subscript 0 subscript 0. That is what will happen for sum equal to this a subscript p subscript q. So a subscript 0 subscript 0, and then this addition plus, and then this b subscript 0 subscript 0. It will be doing in this manner, right? So what will be the answer for sum 0, 0? The resultant matrix we'll be getting will be equal to A0, 0. What is A0, 0? A is your name of the first 2D array, right? So A0, 0 means 0th row and 0th column. So therefore this 3. That is for this A0, 0, this 3 plus this plus and B0, 0. B is the name of the second 2D array. So 0, 0, that means the value is 1. So therefore 1. So therefore resultant 4 will be stored at, right? Again this q will get incremented because for q is equal to 0, q less than column. We have to add these elements row wise. So for 0th row, when we add 3 plus 1, then we will proceed to the next element. Q gets incremented, q will become 1. So then therefore sum 0 and then 1, it will be like this. It will be like this, and this again, this will be 1, this will be 1. In that case, what will happen? Sum 0, sum subscript 0 subscript 1 is equal to, so 0th row and first column. So 0th row and first column, this is 0th row and this is first column. So therefore we will add 2 here. This A01 will be 2 plus B01. So B is this one, second 2D array, right? And therefore 0. So 0th row and first column. Therefore this 2 will be added to it. So resultant we will get 4. So I hope so you understood. In this manner again the q gets incremented, that is column will become 2, and therefore this element will be added, 1 will be added with 3 and it will be stored in the resultant matrix, that is sum 0, 2. And then again here this will be incremented, q will be incremented and this 5 will be added with 1. So 0th row whole elements will be added with the 0th row elements of second 2D array, and for loop will come to end, and again the outer for loop will increment it, that is for the first row. Same thing we will be doing. First row, this element will add with this, this will be add with this, and in this manner we will get the resultant 2D array. So you understood the logic, mathematical operations on this 2D array, how to perform addition. And as I told you, what is must when you are performing addition operation, you have to keep into mind that the order of number of rows and the number of columns of the first 2D array should be same as compared to that of the second 2D array. So let's meet in the next session and let's perform multiplication of these first 2D array and the second 2D array, and we will also see in that case what will be the condition, whether number of rows should be equal of the first 2D array should be equal to number of rows of the second 2D array, as well as the column of the first 2D array should be equal to the number of columns of the second 2D array, whether in multiplication this condition is required or not. We will see all these details.